CII's Technology Committee designed the Technology Path to the Future initiative to inspire a technological step change in the capital projects industry. The aim was to envision the future of the industry with a vigor that challenges industry participants to think boldly. The team conducted innovation workshops and brainstorming sessions with young professionals and established leaders, and what emerged was the Challenge Teams program, a way to give teams the freedom to think big, but with enough structure to sort concepts into 5, 10, or 30-year milestones. Here to present their findings, please welcome Fernanda Leche, Jan Kuhlman, Misha Nikulin, and Todd Sutton.
Hello, my name is Fernanda Leche. I'm an associate professor at the University of Texas at Austin, and I'm joined today by Jan Kuhlman from ExxonMobil, Todd Sutton from Zachary Corporation, and Misha Nikulin from Bechtel Corporation. We are here representing Technology Committee 04, the Path to the Future research team, to talk about technology and innovation in 2050. Our team came together in July 2019, and we had a charter of re-envisioning the delivery of capital projects. And we actually started our creative process looking at cartoons such as the Jetsons from the 1950s. And a lot of these technologies that were envisioned by cartoonists and artists in the 1960s really inspired an entire generation of scientists and engineers to develop these technologies that today, many of which are very ubiquitous in our lives. So our goal is to really inspire, that's the key word, inspire a technology-based step change in the capital projects industry by really thinking boldly and thinking outside the box. Today, you'll hear about our motivation for this effort, the Technology Path to the Future. We'll discuss our development process, and we'll talk about our results, which include our 12 technology enablers, our 5 initial challenge teams, and a compilation of the results of the 5 challenge teams into a 2050 vision. We began our process by carrying out an ideation process through crowdsourcing. So we wanted to collect ideas from the largest number of individuals that we could possibly recruit to help us envision this future of capital projects. And we initially thought of recruiting the next generation leaders, so current college students, since they are unencumbered by their previous professional experience. So we carried out 3 workshops, 3 innovation workshops, one at the University of Texas at Austin, at Carnegie Mellon University, and at Georgia Tech. And these workshops, we had over 100 students participate in all of them. We consolidated, collected all the ideas from the students in these workshops, and had the technology committee in our fall face-to-face meeting distill and help us make sense of all of these ideas that the students came up with in the crowdsourcing workshops. This resulted in 12 technology enablers and our 5 initial challenge teams, which were launched earlier this year. So then when we had this idea of carrying out workshops in various universities, we also had the challenge of how are we going to recruit college students to come and spend an entire Saturday afternoon with us in these innovation workshops. And that's where we came up with the idea of the Mars Industries Workshop. So the idea is that it would be a simulated boot camp for entrepreneurs that were planning ventures in Mars. And we thought about Mars because Mars has a lot of unknowns, a lot of unfamiliar situations, lack of resources. You don't have access to the same things you would have here on Earth if you want to build a new venture in Mars. And that would place the students in the exact mindset that we wanted them to have, to really think beyond how we currently design and deliver projects, but thinking in a whole different way if we didn't have access to the things that we have here on Earth. And we wanted to recruit a variety of majors, people with different, beyond our traditional disciplines of engineering, so much beyond engineering disciplines. So we actually recruited them through this very vague poster. This is one of the examples of the poster that we pasted all over these 3 universities. And we were able to then recruit a variety of students from various different majors across these 3 universities. And these workshops happened in 3 different days, and these were face-to-face workshops. So this video will give you an idea of what we did in this workshop, and I'll let you watch the video, and it'll give you a better sense of what happened.
We're trying to envision what the future of the construction industry will look like. We wanted to crowdsource individuals that are unencumbered by their own personal and professional experiences.
So we came up with the idea of using university students.
I'm Andres. I'm a 3rd-year mechanical engineering student.
Architectural engineering.
Civil engineering.
I'm actually a high school student.
And we're deliberately targeting students because they don't have experience in the industry. And we believe that they have more creativity and will help us generate that path for future construction projects.
One thing led to another, and we were brainstorming about the industries of Mars and how Mars would provide a big pull for the students.
You get to really work with a group of people and get their ideas, but also exchange ideas with other groups, and it really just makes you look at the big picture.
The idea of placing them in Mars is just to add a set of constraints in terms of no access to certain infrastructure that we take for granted, and that just adds another layer of challenges.
So they don't have to think about improving things, they think about creating brand new things that hopefully will generate a step change in our industry.
So as you saw, we had a lot of engagement from these students during these workshops. They were very enthusiastic about really rethinking how we could build in Mars. And by rethinking about imagining how we could build in Mars, that was helping us think how we could build in a whole different way here on Earth. And we had, I'll point out this table here on the left-hand side of this slide, and this table had 3 generations of Carnegie Mellon engineers, one of which, the older gentleman there on the blue vest, he's a retired NASA engineer. So they were on campus that Saturday afternoon, and they saw our poster, our vague poster, and it was family weekend that weekend, and they were together enjoying their day, and they saw this poster, decided to come and participate. And it was a treat to have 3 generations there participate in our workshop, especially a retired NASA engineer who really enjoyed the experience there. At the end of these workshops, we were left with thousands of Post-its that we had to catalog, classify, organize into more manageable pieces of information. I literally had Post-its nightmares the nights after these workshops, because it was a lot of information to sift through. But after going through this analysis process, that's how we came up with our technology enablers. And we were trying to answer this question: how can we enable the efficient performance of valuable actions through these technology enablers? We came up with 12 technology enablers ranging from transparency and trust to environmental sustainability. And these really came up from the ideas that the students had, that the participants in our technology committee, the technology committee members also had and added to. And I'll give you an example of 2 of these technology enablers so you understand how we can use this information. So number 3 here is equipment and facility modularization, and number 10 is automation. For equipment and facility modularization, we mean division of a system into physically and functionally distinct units. And this is important because that way your attention can be concentrated on particular modules or the interface between modules. And that means equipment and facilities can become more agile through a variable capacity and multifunction. And you'll see an example of this in one of our challenge teams results. Number 10 is automation. And by this, we mean minimizing human involvement in design, construction, maintenance, and operations without adversely affecting process reliability. The importance of this is that it really frees human capacity to be used for innovation and for high-level thinking. You'll also see examples of automation in our example challenge team output. So now Jan Coleman from ExxonMobil will discuss the process in which we undertook to develop the challenge teams.
Thank you, Fernanda. So in addition to collating for the prerequisites, we also managed to come up with the 5 challenges from the Mars Industries work. For the challenges, we assembled a team comprising of a student as well as representatives from both an owner and a contractor. The 5 challenges that we came up with were no cranes on a construction site. So imagine a project where tower cranes do not exist, yet the requirements for lifting and placing remain. The project will eliminate the unproductive components of crane usage through alternative technologies or increase the productive components of crane usage to include significantly more usable tasks. The second team was no people on the construction site or in facilities. So imagine a project that is constructed, operated, maintained without people by reducing or eliminating human interface through the implementation of construction automation tools and systems. The third team was maximize information availability through a capital project's AI. So imagine a future where a capital project AI makes all routine or mundane decisions on a project and supports humans in only making the critical, chaotic, or experimental decisions. The third team, no permitting process. Imagine a project where planning permission is granted instantaneously through an artificially intelligent automated process. And then the final team's challenge was from green to black. Imagine a future where capital projects are seen as a green industry. All construction materials will come from either the circular economy or locally sourced, preferably both. All energy used on the project will come from consistently produced renewable local energy sources. Just want to quickly talk about how technology development is exploding. It's an exponential growth. The rate of change of technological development is exponential. We can expect at least the same amount of advancement in the next 30 years as we have done in the previous 90 years. To imagine a future 30 years from now, we must understand and overcome the limitations of today's technologies, as well as envision technologies that must emerge in the future. So a quick overview of the assignment. The assignment for each challenge team was to develop a vision for how the challenge can be fulfilled by the year 2050, along with 10-year and 5-year milestones. The vision should imagine any needed prerequisite technologies or methodologies and be unencumbered by the limitations of today's technologies and business processes. To give a sense of urgency, we only gave each team a 6-week sprint. For an example of a team output, I'm now going to hand it over to Misha Nikulin from Bechtel Corporation and Todd Sutton from Zachary Corporation.
All right, thank you, Jan. I'm very excited to be here and really appreciate the opportunity to talk today about the no cranes possibility in 2050. So we were giving a challenge as a team to imagine a project site where cranes don't exist. we were tasked to evaluate either no cranes technology solutions or modifications, and with a few enablers that we'll walk you briefly through today as well. So our team had two representatives from Bechtel, myself, Misha Nikulin, and my colleague Jennifer Monreal from our physical prototyping innovation practice at the WATSI, or as Welding and Applied Technology Center. We had two employees from Zachary, Todd Sutton, who was introduced earlier today and is co-presenting with us today, and Jai Rahman, and from UT Austin, Abdullah Al-Suhaibani. And as a team, we came up with a vision for our challenge task to accelerate solutions that will potentially eliminate tower cranes on site. And you can read that vision vertically in blue. What you can also see here is the full version of our vision, which says accelerate the creation of the most efficient lifting and placing solutions for capital projects by leveraging emerging technologies that will positively impact productivity and safety and potentially eliminate tower cranes on site. So with that vision, I would like to ask Todd to present next our ideas.
Thank you, Misha. Come join us on our path to the future. Team 1 No Tower Cranes 2050. We look at flying things, robotics, new materials, additive manufacturing, emerging technologies, and crazy ideas year 2050 and beyond. Imagine a job site with no tower cranes. Ideal number 1, heavy duty drone. Here's an example from Griff Aviation of the Griff 135, capable of lifting 500 pounds. Ideal number 2, strong magnetic field. This is an example of a 300-pound toolbox being lifted with a magnetic base on the Griff 135. Ideal number 4, crawling robot. This robot can transverse the structure either vertically or horizontally to place materials. Ideal number 5, lighter materials. This is shown with a gantry crane system and can navigate the structure horizontally and vertically for material placements. Biomaterials. This is biomason, where they're growing concrete bricks from bioorganisms. Ideal number 6, no gravity bubble tent. Crazy ideas 2050 and beyond. Here we have able to assemble modules on the ground and prefabricate spools for placing in place. Here's the Sky Picker from Vertical Solutions. It's a temporary crane system. Ideal number 7, additive manufacturing. This is an example of a 3D printed foam platform. Now we're showing the Hassel EOC NASA Mars habitat submission, where they're using resources on Mars. Ideal number 8, flying platform. This is a flying platform that can carry materials and place materials. Again, another example from Hassel EOC NASA Mars habitat submission. Now I'll turn it over to Misha.
Thanks, Todd. So really, the creating the excitement about the whole effort was key. And first, you've got to really believe in the possibilities yourself. You need to put yourself into the yes and mode. And as we say in the design thinking framework terms, and this makes it really contagious for others. And we focused on generating the excitement first during the kickoff meetings. And then next, we didn't really jump to content writing right away, but we started with structured ideation and brainstorming process. We did use Microsoft Teams as a tool to efficiently collaborate remotely as a team. And in my role, heading the entrepreneurship practice on the Bechtel Innovate team, which is led by our Chief Innovation Officer, David Wilson, we also have design thinking experience and expertise, as I mentioned, and leveraging this entrepreneurial experience, we made the brainstorming session really fun and productive. One evening during this challenge, my two daughters, one just finished high school and one is in the middle school, and we got together and generated ideas that I then turned into these handmade sketches, as you see here. And then Todd on our team brilliantly incorporated some of them into the video material that you saw earlier. So the way it goes is that you start brainstorming with incremental ideas first. And then you push yourself beyond the foundational layers. And then you start adding constraints and different conditions, like no physical restrictions or no human limitations or no budget limits. So that way, Todd and I really guided the team to suggest additional interesting ideas, like the ideas that are really replacement versus modifications, things like autonomous construction and so on. So we spent some time, in addition to that, dreaming about the moonshot, crazy type of ideas. As often a breakthrough would be a moonshot type of idea that you can then pull down to reality. So these sketches do represent some of these idea categories. And the brainstorming really effort resulted in 18 distinct ideas, as you can see on the slide, that support our No Crane challenge vision across 6 different themes. So the flying things, the different drones, platforms, magnetic fields to be used there for flying. We had lots of ideas in that space, and this was the first very kind of easy to get into the mode of ideating type of category. Then we moved rapidly into robotics, as Todd showed earlier in the video, the crawling type of robots, sliding robots, different ideas in that theme. New materials, we expect a lot to happen in the space in the coming years. Lighter materials, biotechnology, as well as moving into additive manufacturing with things like on-demand 3D printing. At the bottom, you see various ideas around emerging mechanisms, things like jet-style mechanisms or exoskeletons that are becoming more popular. And on the right, those crazy moonshot type of ideas, like tent with no gravity environment, for example. So in closure here of the section, starting with the ideation process really helped us to get into the mode of being connected with the effort, and everyone contributed, everyone really connected. So we have a couple of reflections here to share with you on the process. I'll cover one, and then I'll ask Todd to comment on the second one. The first one was really amazing that we had the students to be part of the mix. It was fantastic, and the strong mix of academia, owner organizations, EPCs. This was really well structured and well organized, and it helped a lot for us to have this diversity of different opinions. And then Todd, would you like to talk a little bit about the collaborative process that we had?
Yes, Misha. Yes, this was really amazing project to work on, but mainly because it was such a streamlined project, only having 6 weeks to work on it. It really allowed for us to work as a true team, and also, allowed us to bring the ideas, and really empowered all the team members. Everybody was empowered to contribute to this project, and then it just really helped us kind of consolidate the innovation exploration that we're already doing in our own companies too, to see that other companies are looking at these other solutions as well.
That's right. Yeah, it was absolutely great to see all of us that we were all aligned on some of the future approaches, really confirming the prioritization of certain areas like AI, robotics, autonomy, human aspects, standardization, regulatory challenges. So this was really great. And with that, thanks again for the opportunity to participate in this challenge. Thank you.
Thank you, Misha and Todd, for representing the No Cranes Challenge team. As you can see, they did have lots of fun in the process. And there were 4 other challenge teams that also carried out similar types of challenges. And we wanted to give you a sense of what one of these outputs was like through Misha and Todd. So thanks again for sharing your process with us. So after the challenge teams were completed, we compiled the results of each of the 5 challenge teams in a vision board. And this vision board includes all these different technologies that these teams came up with, including lifting without cranes, autonomous inspection through drones, autonomous robot teams, and a remote command center. So as you can see, these are like the crazy ideas, the moonshot ideas that these teams came up with that can help us envision what 2050 is going to look like. And this is going to change based on what types of challenge the teams are given. But the idea is that it can provide you with inspiration of what we can expect in 2050. One of the major outputs of this research towards the end of the process was the viable paths framework. And this framework can enable CII member companies develop their own challenge teams program internally. So it has a step-by-step process of how we facilitated this process within these 5 initial challenge teams. But it has enough information that if you want to develop your own within your organization, you can do so and encourage people to really think in a more innovative way through these challenge teams. So the first step is really to map your system. What is it that you're interested in, you're passionate about? So an example would be the no cranes on job sites. So that could be that the lifting is the system that you're interested in innovating. The dare to imagine, this is really to think about an extreme. If we place people in the extreme, that's what we did with the students through the Mars Industries workshop. We placed them in the extreme. With the challenge teams, we said, no cranes. How do you build without any cranes? Or we said, how do you build without people in your job site? That's an extreme. That really places people in a situation that they really have to think in an innovative way outside the box and rethink that process. Then once you have those ideas, those brainstorming ideas that Misha explained so well and Todd illustrated so well with that video, how do you map them to those technology enablers so that you have some structure of what kinds of investments you need to be making to make those ideas a reality? And finally, it is important to have a timeline to create some milestones of what is it that you need to be developing in a 5, 10, and 30-year period to reach that vision, that moonshot vision. The 5-year period is basically what are the technologies that are already in place now that we can leverage to try to get close to that vision that we're imagining. The 10-year milestones is what are some technologies that might be in other industries that we can adopt in our industry that can possibly make that vision close to reality. So similar to the objective of the technology committee's Horizon 360 team. And then the 30-year vision is really that moonshot idea. And that's what we have to be envisioning now so we can be developing that infrastructure and we can be inspiring scientists, engineers to be able to reach that solution, to solve that problem, to develop that new technology. And that's what that 30-year milestone is. So you have access to the Viable Paths framework in our research report. So we have 3 main key lessons here from this effort: explore, empower, and set goals. So in exploring, we're saying we should all be open and playful to explore new ideas within our organizations. So Todd and Misha explained that like they had fun in the process. Misha recruited his daughters to participate in this process and develop cartoons, which inspired, which led to that development of the video that Todd shared with you all. So they were very playful in their process, and that really kept their minds open to come up with creative ideas. Our next adds the inclusion of students in this process illustrates the importance of empowering our next generation leaders in this envisioning process. They have ideas that we should be hearing. They're unencumbered by professional experience. They can come up with some creative ideas that together we really can come up with some interesting results, which you saw an illustration of today through Challenge Team 1. And finally, it's important to set goals, to develop a framework in which you can carry out a similar sprint, a similar 6-week sprint. There was very specific objectives. There was a structure that was given that they were working towards, and there was the 5-10-year goals that they had to realize that vision. It's important to have a framework for people to work within. And in terms of next steps, we hope to launch new challenge teams through the Technology Committee, and we would like to invite anyone that's interested in participating in new challenge teams to come and join us and come and have fun with the Technology Committee. This is the Path to the Future leadership team. Their names are listed here on the left hand side of the slide. And this picture was taken in one of our face-to-face meetings in Austin. Thank you very much for hearing us out today. And we hope we have inspired you, much like the Jetsons have inspired all of us in our professional endeavors. Thank you.